Hey guys, Mr. Middleton here. Today we're looking at applications of radicals. At the end of this video, you should be able to apply radicals to find side lengths of triangles. Okay, one theorem that you should have seen before and uses radicals is the Pythagorean theorem. A squared plus B squared equals C squared. Okay, this theorem can only be used with right triangles, and the side that is opposite the right angle is called the hypotenuse, and this is the longest side. Okay, the other sides are called legs. Okay, let's look at some examples with that information that you should probably know already. It says, find the length of the hypotenuse in the right triangle if the legs are 4 and 6 centimeters. Leave your answer in simplest radical form. So I'll just draw a right triangle. Doesn't have to be to scale. One leg's 4, the other 6. We're looking for x. Okay, and we can find x by using our Pythagorean theorem. A squared plus b squared equals c squared. Plugging in our values. 4 squared plus 6 squared equals c squared, or I say x squared. Okay, so 16 plus 36 equals x squared. So we see that x squared equals 52. Okay, in order to find x, just like we did last lesson, we have to solve this equation. Take the square root of both sides to do that. And we're going to leave our answer in simplest radical form. So I know we could plug this into a calculator and get a decimal, but we're not doing that here. Okay, so we have 2 times 13 times 2, so we have 2 radical 13. Next example says, find the missing side lengths in each triangle. Leave your answer in simplest radical form. Right triangle, important to know, so we can use Pythagorean's theorem. All right, in this first problem, notice that we're given the hypotenuse here. So as we set this up, we have 9 squared plus b squared equals 12 squared. So our hypotenuse is still on the side by itself. So 81 plus b squared equals 144. We'll subtract 81 from both sides. And when we subtract 81 from 144, we get 63. And so we have b squared equals 63. Okay, take the square root. That's 9 times 7, 3 and 3. So we find that b is 3 radical 7. Okay, so we left our answer in simplest radical form. Number 2, a little tougher here because we have radicals, but we can square radicals. We've done it before. Okay, again, we'll notice that the hypotenuse is given to us. It's 5 radical 13, so that needs to be on a side by itself. So 5 radical 7 squared plus x squared equals 5 radical 13 squared. And I put this in parentheses because when you type this into your calculator, this is how you type it into your calculator if you choose to do it that way. Okay, otherwise we're multiplying 5 radical 7 times 5 radical 7. Okay, and so when we do that, write this up here, our rule is outside by outside, 5 times 5 is 25. Inside by inside, radical 7 times radical 7 is 7. 25 times 7 gives us 175. Okay, plus x squared equals 5 radical 13 times 5 radical 13. And that's 25 times 13, which gives us 250, 325. Okay, so now we are solving for x. We'll do that by subtracting 175 from both sides. And when we do that, we get 150. So x squared equals 150. Take the square root of both of these here. That's 15 times 10, 5 and 2, 5 and 3. And so we have a pair of 5s that go out. 3 and 2 without a pair, so 3 times 2 is 6. So I find that the length of x is 6. Okay. On the next page, as we transition there, it says find the area of the triangle below, give your answer in simplest radical form, then round to the nearest tenth. Okay, remember this is a triangle. To find the area of a triangle is 1/2 base times height. Okay, so hopefully that's information we already know. And then we have a right triangle that we're trying to find this missing side. So our hypotenuse is 21 And the other side's x squared plus 15 squared. We should be able to use Pythagorean theorem to find x. So 21 squared gives us what, 442? Am I right about that? 441. 441 equals x squared plus 225. Subtract 225 from both sides, we get 216. So we find that x squared is 216. Taking the square root. Nope, it doesn't work that way. 216 divided by 8 gives us 27. So 8 and 27, that's 9 and 3, 3 and 3, 4 and 2, 2 and 2. So we have 6 radical 6 is what x is. Okay, because we have 2 and 3 on the outside and then 2 and 3 left on the inside. All right, so now to find our area, 1/2 base times height, 1/2 6 radical 6 times 15. Okay, 1/2 times 6 is 3. So 3 radical 6 times 15 gives us 45 radical 6. Okay, and to find that, and I'll just say units squared. To find that rounded, we just put it into our calculator, 45 radical 6, and that gives us 110.2. So 0.22, but to the nearest tenth is 0.2 units squared. Final question here, trying to solve for x. Okay, we'll set up our Pythagorean theorem, 3 radical 6 squared plus 2 radical x squared should equal 4 radical 5 squared. So as we go through and solve it, square each of these. 9 times 6 gives us 54. That will give us 4 times x. Okay, and that will give us 16 times 5, 80. Okay, so subtracting 54 from both sides, we get 4x equals 26. Divide both sides by 4. And that gives us 6.5. 26 divided by 4. Let me make sure that I did that right. 6.5. And so we find that x is 6.5. Okay. If you're having trouble with the squaring that x, okay, remember we do outside times outside, which is 4. Inside times inside, which is x. That's how we got from here to 4x. All right. That is our radicals chapter and application of radicals. See ya.